And we are. Hello, and welcome to Practicalli Clojure with me, John Stevenson. Thank you very much for joining us. And today we're going to cover some more information and some more examples using the Clojure CLI tool. So this week I've got a new microphone, my new microphone here, all the fluffy. Hopefully the sound is good quality. If you have any comments about the sound, please let me know. Let me know that this microphone is working correctly. And any other feedback about the broadcast is much appreciated, either in the live chat or in the comments. Okay. So the last week we covered basically getting started with the Clojure CLI tools, and so this week we're going to go into the kind of under the covers a little bit more and explain in a bit more detail how it works, and then try out a few different things as well to see where the state of of these new tools really are. A lot of people are starting to use the Clojure CLI tools, although Leiningen is still very popular and it's probably still the main tool. There is a steady kind of migration, especially on new projects, to use the Clojure CLI tools. So it's great to see where they really fit in. Thanks, hi Henry. Thanks for the feedback. Okay. Let's go here. Great. So, as usual, the resources are all available on my Practicalli website, and there's the study group, the books, and screencasts. And you can reach out to me using the Clojure in Slack. I'll also add the Zulip channel as well. That's a really nice tool to use, and there are different ways to also sponsor and support the broadcasts and books I'm doing as well. I do have a blog that I started many years ago called jrocket, jrocket.co.uk, and that's jrocket with a 0 in there because I couldn't get the domain name. I'm not trying to be too leaked, it's just that was the only domain name I could get. And it's a bit shorter than John Stevenson, so yeah, there we go. But on here I've actually got 3 articles now around the Clojure CLI tools. So the original one we looked at last week, the getting started with CLI tools. I've also written one specifically for working with CLI projects from Spacemacs, and this goes on to basically show you how to call different aliases. So when we're running, if we create a figwheel project with CLI tools, then it's going to set up an alias that we need to run called fig, and that basically injects the dependencies for figwheel, because otherwise then if we didn't do that, we get errors so we get errors because it's not injecting this a fig alias into the command line. So this is the command line that Cider uses when it starts, and by default it doesn't actually have this a fig in there. So and any other aliases that we want to add, then we would just need to do that as well. So we can do that manually by just going in and changing the command line as we start the Cider jack in. In Spacemacs we can do space U, or in Emacs we can do CU before we do the normal checking command, and that gives us a prompt where we can go in and edit the aliases, and then it all works. And we can do that for multiple aliases as well, and rather do that each time, we can set up something called the .dir locals.l, which is a little elisp script that runs, and it will it's basically setting for Cider mode, it's setting this variable which is Cider Clojure CLI command global options, and we can put in here any kind of combination of aliases that we actually want, because we can actually do, if we look at the top example here, we can actually chain all the aliases together as well. Some of those aliases are not real, but fig build is one that's sometimes used. Obviously once it's built you have a party, and then once you've deployed you can have some hammock time. So if you're using Spacemax or Emacs, that's a handy little article. And so let's get on to the main thing I was going to cover today. So trying to get a deeper understanding of CLI tools. And you don't have to understand everything about the CLI tools. I just thought it was quite interesting to understand what they're doing, just so you can get a better understanding about when they may be appropriate for you to use. So I think one of the biggest things about the Clojure CLI tools that is commented by people is that it just makes Clojure really, really accessible. If you've got, as we saw from the Getting Started guide, it's very easy to install. If you've got like Homebrew on the Mac, it's as long as you've got Java installed already, then you can just install it with a simple Homebrew command. And on Linux, it's a simple curl command. There's still a little bit of experimentation to get like a really nice one on Windows, because there's so many different versions of Windows, but there is something that seems to work for most situations as well, which is kind of the same for Leiningen as well. But that's what it is. It's very lightweight. You can just install the CLI tools and it will do the dependency management for you, and you can also add extra libraries to do some additional features. But I think the purpose of the Clojure CLI tools is to be very simple, very lightweight, and very easy to work with, and you can build very flexible projects and very flexible workflows around these tools as well. Because essentially the CLI tools, you can consider them as a wrapper around the kind of calling and running Clojure from the command line using the Java command. So when you install Java, you get Java, which is the runtime environment, so you can run any byte compiled jar file, any compiled. So if you're compiling Java or Scala or Clojure, they're all going to be a jar file, which is a Java archive, and you can run that using the Java command line and just specifying the class path. And you can also run the source code as well, just using the Java command, and we'll see that in a moment. And it also does library dependency management. And the nice thing is we can get it from different sources. So we'll do some examples where we get, instead of using a jar file, we can just use a GitHub repository as well. So that's really kind of flexible approach. So let's have a look at under the covers. So so here I've got an example where I'm going to create a Leiningen project, but then we're going to play around with it. Rather than use Leiningen, we're going to actually use the Java command line, just to show you, if you've never used it before, it's actually quite tricky to find the right information about this as well. So obviously people don't use it, but this is sometimes, the Java command line is sometimes what you actually use when you're running applications in production. Because again, if you package your application up as a single jar file, it just makes the deployment very easy and self-contained, and less likely to rely on the operating system for anything as well, which is a really good practice. So if you look at things like 12 factor, let's see if that's going to find that. Yeah, if you look at the 12 factor app, then one of the things it mentions is dependencies. So it should explicitly declare and isolate dependencies as well. And I think, does it say anything specifically about yeah, so I think in here it talks about also kind of being, as well as the dependencies, also kind of being isolated from the operating system as well, because you don't want to depend on anything in the operating system because it might change. You just want to use the operating system as a way to talk to the hardware, essentially. That keeps it nice and simple. So let's do some coding. Well, let's create a project. So I'm just going to go to a terminal, and I'm just going to create a project. I'm using Leiningen because it's just really quick and simple. We used the CLI tools previously, but I just want to show you like how it used to be, how you could kind of do it in the before Clojure CLI tools. So we've created this new application called Classic. I'm using an app template as well, so it just means that we can actually run it on the command line. So we could, if we switch back here, so we could run it with line REPL, and that would give us a REPL. But it also compile the source code as well. So it would compile the source code into Java bytecode. So we'd have a whole bunch of classes in there. So let's do that. Oops, what did I do? Oh, that's interesting. So we do line REPL, then this is going to pull down any dependencies. I'm pretty sure I've probably got all of those already, so it should just run the REPL. There we go. And so underneath it's actually going to, I should now have a target directory running on this. Ooh, my laptop's going a little slow this morning. There it is. So we've got a REPL. I'm just actually going to quit from that. I'm not actually going to use that at the moment. Bye for now. So if we look now we've actually got a target in there. We're going to target. And so you can see we've actually got some classes in here as well. I think we should have some. Maybe not. Okay. There we go. Oh, yeah. Oh, my class is gone. Oh, interesting. That didn't work. Well done. Sorry, it's 9 o'clock in the morning. I don't know what I'm doing. There we go. There. Projects. It has been a while since I've done this, so I can run the program with line run. I get the results there, and so can I also do that with the Java command line? Let's have a look. So we can so we can call, so we haven't created an uberjar yet, but I would have thought we should be able to do this. So as you can see, this is quite long, so I'm not going to type it all in because I'll get it wrong. But let's see if we can paste this in correctly. So what this is doing, this is calling, this is using the Java command rather than Leiningen, and we're going to set the class path, and the class path is going to be maybe it's only doing that when I'm doing an uberjar. Okay, interesting. It has been a while since I've done this. Okay, So I'm not sure if that's going to work. No, okay. So if I do line uberjar, it'll definitely compile everything now. So this is going to create this single archive for me, and there's a CLI alternative we'll mention as well a little bit later on. So this is creating this actually creates two jars. So it creates this classic 1.0 snapshots and classic 1.0 standalone. And if we actually looked at the differences between those, let's see if we go into target uberjar, and we can see that one should be slightly bigger than the other. Actually, one is quite considerably bigger than the other. So this is only in, what is this in? Let's do this in proper units. There we go. So we've got 14K versus 4.4 meg. Still not that big, but it's a lot bigger than the snapshot jar. And the reason is that this classic snapshot standalone also includes the Clojure library as well. So it's not just your application, it's the whole Clojure library. And when I mean that, it's not just the language, but it's also the Clojure runtime, the REPL, and all the tooling that comes with that as well. So that's why that's bigger. And so now if we have a look what we've got here. So in here we've got classes, which is what I was looking for. And so we can go into the classic. Is it done? There you go. So there's the classes for my that have been created for my project. And you see they've got strange names, but that's just the way it is. When you evaluate a file, when you evaluate some expressions that are defining code, you might see similar kind of names, especially like inline functions that you're using. But we see we've got a core class and a core init class, and so we can actually run these from, because they're just Java bytecode, so we can actually just run them from the Java command line. So I'm just going to get back up the path. Are we in the right place? We're in the right place. So we go back to that very, very long command I had here. So now we're basically just adding all those classes from the target to from target uberjar classes. So we're putting those on the class path so Java can run them. But if we're just using the classes, then we don't have Clojure in there, so we don't have a Clojure library. So we also need to tell the Java command where Clojure is, where the Clojure library is. So we can see we've got, because I've used Clojure before, in my Maven cache, my local cache, I've got org.clojure, Clojure, and I'm just using 1.8 here. Have we got 1.8? I might not have 1.8 in this machine, I'm not sure. Let's have a look. I do, there we go. So I'm running that, and it prints out the hello world, just like line run did. So they work pretty much the same. One of the reasons to use the Java command line rather than line is that unless you use something called trampoline, then line starts up two Java virtual machines, one for itself, so it can run its own commands, and it can run plugins and so on, isolated from the rest of your application. So it does use a little bit more resources. So in production, then it makes sense to run Java in like the Java command line instead. And because we've got a jar file, then we can also just run that jar file as well. So we can see here that if we use the standalone one, then we can we don't actually need to specify Clojure because it's already there. So we do Java, and then we're going to specify a jar file that we're going to run, which is going to be in target uberjar, and we use the classic and we use a standalone version, then this should also give us the same hello world results. It does, there we go. And we don't need to, with this one, we don't need to specify the actual main namespace, because it's kind of already done that from the code that we've used. So if we have a look at the project file, let's have a look at this. If we open not hello world, Clojure CLI, and then classic, and if we do source, classic, the namespace, and core. So this is all the default code that's been created by when we did line new app classic, and it's got this gen class directive here in the namespace. That means when we compile when we compile the code into an uberjar, it's going to create a specific class. So you saw that we had like a main.core and a core. So we had a core class and a core init class. So Java's got some way to hook into that, so it will see that, and Clojure will, by default, it will call this main function. That's what it looks for by convention to as the kind of entry point into your application. And as you can see, it doesn't actually do a lot. We could also give it some arguments in here as well. So for some reason this takes arguments, but it doesn't actually do anything with it. And so we can just do we could just reduce string of args. I think that should work. And then we would need to recompile. So if we rebuild the uberjar, I could probably just type this, it would have been quicker. So this is just going to overwrite the jar file that we just built. Hopefully it won't take too long. There we go. So you can see it's compiling classic.core and it's created the uberjar. So now we should be able to call the uberjar and also give it we'll also be able to give it an argument, which will be sent through as an argument to the -main function. There we go. Oh. There we go. And let's see if that worked. I haven't tested this, but so yeah, there we go. It works. Excellent. So it's pretty easy to use the Java command line. Unfortunately, it's the command line, as you can see, is already getting quite long, and it's very prone to errors, and it's very easy to forget what it is, and it's quite difficult to actually go and Google stuff like this as well. There are other search engines, obviously. So let's go back to the article. So that just shows you how we can use Java as a command line, and you can like fire in Java JVM ops again, which is quite useful when you're putting things into production. But if you've got a long list of dependencies that are separate, and you don't have like a single jar file, then obviously the class path gets quite long. If you don't specify that gen class, you would need to use cloj-main and then specify the main namespace to start in as well, and then you might have port and other environment variables that you want to inject as well. So it could be quite messy. You'd have to build a script, and the problem with the script is that there's no way to kind of validate that script in a meaningful way, not certainly in a way you can validate Clojure. So with the CLI tools, you're really kind of giving you this Clojure command, which helps wrap all that up, and you can use the deps-eden file, which is just a Clojure file. It's actually just a Clojure map, and it's so much easier to validate and to check a Clojure map than it is to do a a shell script and so on. So it's and it's a lot easier to maintain and work with that depths Eden closure map as well. Any questions? No questions so far. Excuse me for a second. And okay, so Clojure, so we've already seen from the previous episode, last week's episode, we saw Clojure and CLJ. So Clojure is a command and CLJ is the kind of wrapper around it, which gives us a slight improvement in the command line experience. And we've got, once we install depths Eden, we get a bunch of configurations, so we can just actually use Clojure straight off there to run a REPL, so we don't need any other configuration file. So if we just come out of this project, we can just use CLJ, and it'll start a REPL, and it'll use the defaults that were there in the install, and any defaults I put into my kind of global my account configuration. So it's using Clojure 1.10.1, and we've got a working REPL. And you can see, because we're using the wrapper, it's doing the parentheses matching, it's highlighting the when we've closed that parentheses there as well, so it gives us a nice visual indication. And it works. There we go. Let me just kill that. And so this is working because we've got the when we installed it, when I installed Clojure Tools, CLI Tools on my computer, it's put this file in called depths Eden, which is an example file, and it's put this into user local lib Clojure for me. That might be different on a Mac, but that's probably where it'll be put onto a Linux machine. And when you run Clojure or CLJ, it also creates an example depths.eden in this .clojure file in the home of your account directory, and it's doing things like it's setting the path to where to look for code. You don't actually have to have any code to run a REPL. You can just run a REPL, so you don't even need to set up a project with this. You can just run it. You can do the same thing with Leiningen and Boot. And we're setting the dependencies. We're setting what version of the Clojure library we want to run. And so if we don't specify anywhere else what version it is, it will just run the version that's part of the install. And it's also including this tools.depths.alpha, which is quite important because this is doing a lot of the heavy lifting for us. So rather than having to craft our own command lines to run this, it's going to download the dependencies, which is very handy. And it's also going to build a class path for us for the project. So it basically wraps and abstracts away all the hard work we would need to do otherwise. Because this is an easy install and it's only using, and it is just a wrapper on top of the Java tools, Java command line essentially, it's only going to start one virtual machine, so it's actually really good for using this in production tools as well. So if you're going to deploy with production and you want to move away from using the Java command line, then the CLI tools are an excellent option there. And finally, it's highlighting where the Maven repositories are, and so these are common repositories of libraries, and these are jar files. So we're using. So we haven't used anything different from jar files yet, but we can. With Clojure CLI tools, we can actually use GitHub repositories and local file systems and so on. So that's what we get for free. Oops. And we can create so if we wanted to create a project, we did use a tool called clj-new last time, but let's create one from scratch just to show you how easy it actually is. So I'm going to copy this. Oops, not the line numbers, that would be wrong. So where are we? We're not in a project. I'm just going to make a folder called simple, and that's going to be the title. That's just going to be the name I'm going to use for the project. Let's go into simple. Oops. Simple. And there's nothing in there. There's nothing up my sleeve. I don't have sleeves. There it's pretty empty. But we can create a deps, just a blank deps.eden file in there. And then I'm just going to open that in my editor. Clojure CLI, simple, deps.eden. And I'm just going to paste that code in from the article. And so what are we doing here? So we're actually putting in some of the things that are already there. So there's already paths. Path is already there in the install, as was Clojure. We could actually go in and change. If we change this to 0, then we could actually see that that should. I think that should overwrite it and should use the different version of Clojure instead. Let's just check that's working. So we've saved deps.eden. We're going to go back to the command line. So we've just got a deps.eden file here. If we do clj, press enter, and give it a second or so to start up, starting up the Java virtual machine, and then loading in Clojure REPL. And it's using Clojure 10, 1.10 instead of 1.10.1. So we can very easily use lots of different versions of Clojure. We can even go back, well, I'm not sure you want to go back further than 1.8, but you could go back all the way back to Clojure 1.1 if you wanted to, and it should still at least download the dependency for you. Whether it works with your code or not is a different matter, but it depends. If you're just using the core part of the language, then it should work just fine, because Clojure is really, really backwards compatible. Excuse me. And so, yeah, so then we've got a REPL running whichever version of Clojure we wanted to, and that can be a different one from the one we use generally. So that's just in the deps section. It's just creating a Clojure. We're just adding a Clojure library, and then we're using the Maven version of that, and the classic way we specify versions. So we've got major, minor, and point releases in that. So, but this isn't the only way we can specify dependencies. We'll see in a moment. We've got an alias. So aliases are a way to kind of build up different ways to run your application. So we can actually just run tests. Rather than running the application, we'll just run the tests of the application as well. So it's we can set up different things. In the test, we're setting up extra paths. So it's not just going to look at source, it's also going to look at test. We can set up additional dependencies, extra dependencies here. We've got this Cognitech test runner, and this is what would run our tests for us. And so we could probably put in here whichever test runner we wanted in here. And the aliases are really flexible, so we could actually have like different tests using different test runners if we wanted to try out different tools and see which ones we actually preferred. You can just add them all in as different aliases and call them to see how they perform on your application. But as you can see, so we've got the name as usual for our dependencies. Yes, and so this is overriding. This is the deps.eden in the project file itself, and that will override anything that's set in the .clojure/deps.eden file, and that file will also override your global one as well. So we have the we have the deps.in that is part of the install, which sets things for every project, but then that can be overridden by the user deps.in, which is in your ~.clojure directory, and then you have the project specific one. Oops. I can't type anymore today. Specific, which will override the other two if there are the same thing. So it's basically merged, because they're maps, it's basically just merging those maps together, and if the project specific one has the same entry in there but a different version for a dependency, then it's going to use that dependency. So it's really easy to hone down and finesse a particular project to do exactly what you want, while still using all the common general configurations you want for projects. That's a good question. And so we've got these extra deps. So there isn't an extra deps in either the other two, I don't think. Let me just open. Let's see if I added anything to this. Let's go back to Practicalli.Clojure and see I've got a deps in already. I think I added something to this last week as well. So we do have some extra deps in here, but that's part of this new alias. So that's not going to be affected by test, and we don't have a test alias here. So we could actually have a test alias here that defines the generic test runner that we actually use, but then for different projects we could use different test runners, and especially if we're doing different tests we might be using different tools for Clojure versus Clojure script as well. They'll all pull from the CLI tools as well, so it's very easy and very flexible to do that kind of thing. So you see, we could just have test and extra paths in there, and then we wouldn't need to specify that in the project necessarily. Although it's actually, I think it's quite good to specify certain things, because then it just makes it easier for people to understand what's actually going on. So actually specifying paths, even though it's duplication, I think it does make it easier for people to see where things are actually, how things are actually working with the configuration. So you may have noticed already that this extra deps is actually using a Git URL. So we're not using a Maven version, we're actually using a URL. And this is a real URL, so if we press enter on here, it should open up. If it's working today, is it working today? Oops, wrong button. It's not. It's not. There we go. But here is the SHA. So we can see that this is a real commit. It's part of the commit, part of this Cognitex Lab test runner repository on GitHub. And we've got the commit unique identifier, this what's called the SHA, or the SHA-1, and that's a unique way to identify this particular commit in the repository. So you can use this way to refer to a particular version of the code without worrying about it. In fact, so this is a really stable stuff, because even if people do extra commits, then it's not going to change this one. The only kind of minor risk you might have is if somebody did a force push and actually deleted and replaced this commit with a previous commit, but that's a very bad thing to do in general anyway, forcing changes on there, especially on the shared repository, because it just confuses everybody else on the team or in the community as well. But it's even if somebody did that, then it's just a matter of updating to the latest SHA version as well. And so to find this, I just went to the code, went to the commits and say, okay, what's the latest one? And we can go and clicked on the latest commits and did that. But I can also go back and go and select any other commits if I wanted to. So if there's a commit, say this commit broke something for my project, I just go back to a previous commit and just go and use this char instead, or it's also in the URL here as well. So very easy to roll back. You don't have to wait for the project maintainer to do a rollback or to do a new release. You can actually just go in and use the char straight away. And when projects are moving fairly quickly, then this is a real kind of time saver for you as well. So I hope that was pretty clear. So what have we got? Did we go through everything here? Yeah, pretty much. So we've got the git char. So it's just basically the same. It's the same syntax. We've got a library name, a dependency name we want to pull in, and a way to describe the version. So this is our library name, test runner, and this map here is just a way to specify the version. And these main ops is just showing us what the main, as we can remember, sometimes we have to define what the main namespace is for these main ops. That's what we would need to do on the Java command line. And this is just going to call the accompany test runner and the -main function from that and run all our tests. So let's see. So we've got a project now. And we did see that we could run a REPL in there as well. But what we want to do is obviously want to add some code. But if we're doing things in a nice way, we can do things like a test-driven development way. So we basically create a test file, or a file with I've got a couple of tests in here. I'm going to copy that. And let's just create a new file. So I'm going to, yeah, that's the right place. So the path it needs to be in is source. So we need to have a source directory. And we also need to respect the namespace of this. So the namespace is simple. And we're just going to call the file core for CLJ, and it's a Clojure project, so we just call it core.clj. And that's created the file for us. Let's just do that to be. Oops, that's not what I want to do. That's the source file. Oops. Yeah, I want to create all those for us. Actually, if I'm doing TDD, so I want to create the test file first. So let's do. Let's go back up. So we also want test. The same again, simple for the namespace. And let's call this core underscore. Where's my underscore gone? There we go. Test. So it's the same name as the file that we're going to test, except it's got test on the end. CLJ. And we can just paste that in there as well. See, we're having to call the file core underscore test rather than core dash test, even though that's the namespace, because even with Clojure CLI tools, it still doesn't like, Java still doesn't like the dashes in file names, in directory names, so it causes a problem. So we have to use the underscore instead, and it's something that Leiningen also manages for us as well in some respects. I'm going to create that. So we've got two files. One's empty, one's got a test in there. So we're going to require the simple core. This is the system under test that we're using. So just using this SUT as a way to refer to all the functions in that simple.core. we want to call them. And we're including clojure.test. So the way we require things doesn't change for a CLI as well. It's exactly the same code. It's exactly the same syntax of Clojure. And we've got a couple of tests here. So if you've not used def test, we're just using def test function to define some assertions, and we can put it in a testing function to kind of give it some context. And here we've got two assertions. So if you're used to Java, this is just like an assert. This is just is something equal to something else. So we want to just see whether the two things we give the equals function are the same. So we're going to call the main function from simple.core and see if it's the same as hello world, and we'll do the same thing but also using an argument as well. Okay, that's saved. So if we just go back to our deps.eden in simple. So to call our test runner, then we can just use the alias test, well, colon test. So let's see here. If we go back to the command line, so originally we just called clj, but if we give it an alias, so -a is going to specify we're going to give it one or more aliases, and then the name of the alias, which is test. So this should now run our tests for us rather than running our application. Fingers crossed. Oh, and look, oh, that's not good. Oh yes, that's okay. That's an error that I can understand. Oh, look at that, huge stack traces. If I switch back to Clojure 1.10.1, actually those stack traces should be a lot smaller. But you can see that the first thing it's doing is actually, well, it's already got Clojure 1.10.0 because we already run this program, so it's already downloaded it if it didn't already have it in the Maven cache. But we didn't have the test runner, so we're actually cloning that. So we're actually going to GitHub test runner, and it's going to pull down all that source code. It's pulling down the specific SHA, and it's also getting the tools.cli from there as well. And this is just complaining that there's no, we go right down to the bottom. Oops. Yeah, you see there's no such var, so there's no such var software under test /-main. It's because we haven't created one yet. So that's a perfectly reasonable error to have. So if we actually go in and create, or add the code, so this is what we've done. We've just basically done that. Oh, actually, yeah. So you can see this is. I'm going to change that now. Let's go and change that before I add the source code. Let's go and change that back to just see if that's the. We jump to 10.1. The Clojure Cognitive Tech team are doing an excellent job in improving the output from stack traces, and 1.10.1 does a really good job of doing that. So if we do we run the test again, then hopefully this time it'll still fail, but hopefully it gives us a nicer output. It'd be nice to double check that. So I don't think it will clone the, yes, it didn't clone. Oh, look at that, it's much nicer. So that's the great work that the Cognitive Tech team have done to make the output of stack traces so much easier. So it's actually just showing you the line that's actually valuable. So it's telling us where it thinks the issue is, and it's actually giving us a meaningful error message as well this time, so that's really great. But it's also showing us, I think this is the whole stack trace. Here, let's just go and have a look, because that would be quite cool as well. Because sometimes you do need to go and look at the stack trace. Yeah, but the stack trace as a Clojure map, so that's nice. That's much easier to work with than your average stack trace. And so if you're used to using error tooling for your, especially for your production systems, then they're, rather than just sending a string of text, they usually sending back an object, which makes it much easier to search through the error messages. And so the Eden file, so when we got an error, then the latest version of Clojure 10.1.10.1 is actually generating this file for us, and with the whole stack trace in there, and just giving us the most relevant part of that. So that's a really good motivation for actually upgrading to the latest version of Clojure. Cool. So actually, let's go and fix our tests, because we don't want broken tests. We want to have the tests working. And now some code. There we go. So this is just a really simple. Well, no, I think we can do better than that actually. But there we go. Where's my edit? Where's my editor gone? There we go. So if we open the core.clj, so there is no var, and there is a var now. Actually, that's the wrong one. Ooh, I might need to update my blog a little bit. There we go. And instead of print line, oh, we want args, don't we? So reduce. And I'm using a reduce for the args to make that, because if we have multiple args, I just want to convert them all into a single string and add them to the end of the print line. There we go. So we save that. Let's go run our tests. So it's going to compile. It's compiling both the source code and the test. Oh, I've got some errors. There we go. So it is running the tests. It's found so that mainly it's just giving us slightly different answers. So again, this is very similar to the Clojure, just running Clojure test in Cider, in Emacs, or any other tools as well, or just on the command line. What's it doing? It's giving us more of a wrong number of arguments. Oh, interesting. Oh, is that because? Oh, yes, because I think my test just. I think my tests are incompatible with each other. That's why. I'm going to look at my tests. Yes, so I'm calling this with. Oh, actually, that should work. Oh, did I get my code wrong? I wonder if I got my code wrong. Let's have a look. Yes, there we go. I defined my main to just take one argument when I wanted multiple arguments, so I can use the ampersand to say however many arguments I send to main, put them all into a vector and call that vector args. And so then I reduce over that vector using string to put all those arguments into a single string, and off we go. So hopefully my tests will run. Dum dum dum, exciting times. Oh, I've still got 2 failures. I've obviously done something not quite right. I'm getting nil back. Oh, did I? I think I still got something wrong with my tests, but you can see that the tests are actually working in the fact that they're running. They're just not passing the tests. I'm not sure what I've done wrong there. I'm not going to debug my code. I'll leave that for you to do that. See if you can spot any comments. If not, don't worry about it. It's just tests. I can fix that later on. So figwheel-main by itself, and it should just return hello world. Yeah. Oh, yes, of course. It's because I'm using print line. It's actually returning nil. My tests were right. Well, they were working correctly. If I go and look at the tests, you can see that it is telling me that yes, it's returning nil here, which is correct because print line does return nil because it's actually a side affecting function, and it's actually it's putting the hello world on the system.out. So when I compare that, then it's not going to work. So I'll need to use str, and that should work. There we go. I did say I wasn't going to debug that, but I ended up doing that anyway. There we go. So let's see. Last time, and then we'll move on. There we go. Oh, so we're getting oh, there's no space. There we go. I think that's what it's complaining about. There's no space. So that one should work, should it not? Oh, that's doing it. Very strange. Okay. Well, we're getting closer. But you can see we've created a project. We can run that project in a REPL. We can run the tests. We can set up any kind of aliases we wanted to. Just going back into the deps that's not right. Deps.in simple file. So we've only got the test alias at the moment. If we come out of there, so one thing you can do that we did last time, I'm kind of interested to try, is the clj-new. So if I open my, if I have just a quick look at the Clojure deps.in file. You see we added this, where is it? We added this new alias, which calls clj-new, which allows us to create projects from that. So we can actually, so rather than having to hand code, oops, what to do? Oh, I've just locked my computer. Sorry. Oops. Oh. There we go. Oh, well, fingers and thumbs today. I apologize. So if we, what was it? Oh yes. So we're in the top level of where we're putting our projects. So I could do clj with an alias of new, and then I can specify a template, which is kind of composure, which I think is quite a big one. So this is create, if it works, this will create a server-side a web application, but rather than using Leiningen, we're using clj to manage that project. Oh, sorry, yes. I still need to get used to naming it, so you need to kind of, so if I do it practically, that should work. So what I'm doing when I'm naming my projects, I'm naming them Practicalli because that's the GitHub organization that they are all going to go under. If you're doing it for your own projects, personal projects, you just use your GitHub name and then the project name, and then that looks like it's worked. There we go. So this is created on my website. Actually, let's go and look at this in the editor. Let's do my websites, and then we should have a deps.in file in. Oh, it hasn't created one. Oh, that's interesting. So there is some kind of work to do because like some of these templates are working and some of them are not working. So this doesn't seem, so CLJ doesn't seem to work with Composure, unfortunately, but we do have one that we did earlier. We did last week. So if we go back to so it is kind of a little bit of a, ooh, which one did I do? What time is it? No. Is it mine? So here's a different one we've done, and we've got we're using test check in here, as well as the and yeah, we can see we've got two different aliases for running tests. So we've got tests where we're using this test check test library, and so that's doing the generative testing. So it's actually creating a whole bunch of test cases for you based on a specific definition of your tests. And we've also got the test runner, except we just called that the runner alias. And so now if we're going to run the test in here, we would use runner, we'd use -a:\runner rather than test to run this particular different one. So we have many different tests in there, and we can also run all the like the different aliases all at once as well if we wanted to, just by stringing them together. Oh yes, lowercase w in the hello world, yes. I think I did come across that last night. Yes. Thank you for spotting that, Henry. Okay, I'll fix that in the blog post. So what else have we got? I think that's about all I was going to cover for today. Let's see if there's anything else I want to mention before we go. So you see we're overriding. There's a few extra things to add to this post, but we can override any configurations we mentioned before, with project being the one that will override everything else. And we can add JVM options, which is really useful, especially when you're going to do into production. So I'll kind of add some of those things, examples around the JVM options. And we can also configure useful deploys. So for CLJS, I think I've got this. I do have some code examples here where I'm actually setting up a deploy alias, and it will actually build my JavaScript to a different location, because the normal build puts everything in target, and then and it creates an awful lot of individual files in when you're working with Clojure script, because that's the most efficient way for figwheel to work, because it can then just reload specific parts very easily. But when you actually want to deploy something, you might want a separate file, and you might want to just put it in a particular location. So when you just run that command, you don't need to go in and hunt and copy the file over manually. The Clojure CLI tools will actually just do that for you by defining an output to directive in there as well. And yeah, and we can also do deployment, so we can actually create so we don't have to use Leiningen for an Uber jar. We can actually use a little project called Depstar. Again, this is another Sean Caulfield project, which is really, really handy. So this doesn't do, one thing to be aware of, this doesn't do any ahead of tile compilation, but it does, but it will build you a jar file, and it will kind of allow you to deploy that. So if it doesn't do any AOT, your project might start a little bit slower. It might take like a second or two to kind of get going as it loads in all the bytecode and then starts JIT compiling it, but it will work very nicely in that way as well. So there's quite a lot of few things to do, and I also want to investigate creating your own templates. It would be nice to have a kind of list of templates that we know that work with CLJ Tools, so with clj-new, and also write some new templates for clj-new so we can actually have a kickstart. I mean, it is, hopefully you've seen, it's pretty easy to write your own Dependencies file. So it is quite simple. There's quite a few examples out there as well. And you don't really need an awful lot more than this, actually, really, to run your project. So it's very quick and very simple to get going. Usually a lot simpler than the Leiningen project configuration files, and so it's quite nice in that respect. Are there any questions for this? Oh, that's Hello World. I'll just see what I've done wrong with this. See, there we go. I missed the comma out as well. That's all uppercase. That's all uppercase. But that's got a comma. There we go. I apologise, I did do that a little bit late last night. Is that the right one? Oh, that's classic. Where's simple? Simple. Source. Simple. Oh yes, so that's lowercase, as Henry mentioned. There we go. And that's uppercase. There we go. So they're both the same now. Maybe it works now. I'll give it one more try while just see if anybody else has any questions, and then we'll leave it at that. Let's pop out there. So I'll have a play this next week to see what kind of templates work, and see if we can do some more advanced things with Clojure CLI, and see if there are any other libraries that are really useful to include, and aliases to set up. So I'll do a bit of research around that. Yes. I could spend a lot of time debugging this. There we go. Yes. There we go. So the test is space between Hello World and the args. Yes. So I think the first one will. Yes. The first one passes. Woohoo! And then the as been mentioned in the chat, I just need to put in a space in here as well, and then we're working. Excellent. I can code. That's good to know, with a bit of help from other people. Okay, well, I'm going to leave it there. Thank you very much for joining me. I hope you found that useful. And if there's anything else you want to know about CLJ Tools, let me know, and I'll see if we can investigate that. But we've I think we kind of learned some of the more important points here. So we've kind of understood how it's working underneath and why it's useful to kind of abstract that away, and how to also use dependencies from Git libraries, which I think is the real kind of one of the killer features, as it were, for CLI tools, which does make it really flexible to pull all sorts of dependencies just from Git repositories, which hopefully as developers we're all very comfortable doing these days. So thank you very much for joining me. Again, there's more information on the website, practicalli.github.io, and thank you for joining me, and I hope to see you in the next video. Thank you very much. Goodbye.